Hello and welcome to today's webinar with BICS and Cesanta on how enterprises can connect Internet of Things devices to cloud platforms both globally and at large scale. My name is Jeremy Cowan and I am the editorial director of IoT Now, and it's my pleasure to be your moderator today. Thank you very much for joining us as we examine how to manage thousands or even millions of IoT-enabled machines worldwide, and to do it securely with connectivity everywhere, and to do it across multiple countries and with different operators. So for this, we have a distinguished and experienced panel. And first, I want to thank the sponsors of today's webinar, IoT Communications Enablers, BICS, and their partners, Cesanta Software, a technology company specializing in IoT. And finally, we welcome Hamburg-based IoT Analytics. First thing to do for me is to introduce you to our speakers. And in order of appearance, they are Eugenio Pascar, Principal Analyst at IoT Analytics. Great to have you back again, Eugenio.
Thanks, Jeremy. It's great to be here.
And it's a first-time welcome to Philip Gosselet, who is Senior Product and Business Development Manager for IoT at BICS. Really good to have you here, Philip.
Yeah, it's my pleasure.
And I'm also delighted to introduce you to Sergey Lyubka, who is CTO and founder of Cesanta. Thanks very much for joining us, Sergey.
Thank you, Jeremy. Nice to be here.
Now, as always, this webinar is being recorded, and from tomorrow you can access the audio and slides via our website at iot-now.com. We're grateful to all of you, our delegates, for your input, coming as you do from countries as far apart as the US and India, Brazil. If you've already sent us a question, thank you, but it's not too late to send us more questions. You can do that throughout this webinar. All you have to do is just type your question into the window on this screen, and I will put as many of them as I can to our panel later on. And finally, if you're having any technical issues with audio or slides, you can also use the question window. That's just to get advice from our technical support team. What we need first is to understand the situation and the views of our audience. So I'm going to go straight to our poll, and online on screen now you will see our poll, which indicates that we want to know what you consider to be the main challenge for deploying a global IoT project. You can choose any one of these four options. Please start giving us your thoughts on this. Do you think the main challenge is consistently managing connectivity of devices in every country? Do you think it's provisioning of devices when they're deployed in the field? Are you concerned most about control and quality of connectivity service and the applications across all countries? Or would you opt for the last, a number of other options such as business case or technology understanding or cost? So which do you believe is the main challenge for deploying a global IoT project? We seem to be getting a runaway winner on this. Eugenio, let me ask you first. The audience say by quite some margin, about 67, 70%, it's fluctuating as the answers come in, that they think control and quality of connectivity service and applications across all countries is the biggest issue. Give me your brief thoughts on that. Is that what you expected?
Well, in general, yes, I would expect that to be the main reason. Maybe not by this margin, but it is without any doubt that this is a big issue for deploying solutions over different countries, considering that there are always networks which have different situations in terms of coverage, in terms of technology. So doing this seamlessly is definitely one of the main challenges here.
Yeah. Philip, was this your expectation, or is this like Eugenio, that you think this is a slightly higher figure than expected?
I'm indeed surprised by the lead of the winner. At the same time, our customers see that indeed they use us to get, for instance, the best coverage in remote countries in Africa, and sometimes we indeed have to switch operators when one operator is not performing well enough in an area, etc. So it's indeed, it matches my experience at BICS.
Yeah, that's reassuring. Sergey, what was your take on this result?
That's more or less corresponds to the what we see and what we hear from our customers, but also the quite often problem that they report is the security and the problems with the remote control and update of the devices. So the quite common issue is having, so customers may have a device bricked in the field, and they basically see a big cost of replacing or repairing those remote devices.
Yeah.
But overall, that's expected.
Yeah, that's interesting. Thank you very much for your comments, gentlemen. Without further delay, I would like to go over to Eugenio, because you're, I think, in a position to be able to give us the wider landscape to understand the industry's connectivity challenges in a broad view. Over to you, Eugenio.
Yes, thank you, Jeremy. So my discussion today, let's just begin with a small introduction to IoT Analytics for our public that doesn't know about us. We are a small IoT market insight boutique based in Hamburg, Germany. And as the name suggests, our main focus is the market of IoT. We are specialized in particular in industrial topics. We have lots of upcoming reports coming within this kind of segments, industrial connectivity, predictive maintenance, but we are also covering topics more towards connectivity, such as 5G or low power web area networks. And we have several publications on IoT platforms and also smart cities, such as smart metering, street connected street lights, and smart parking. About our discussion today, let me start with this slide. This shows some of the successful IoT projects that are present today. So starting from the left, we have smart connected industrial products. This particular use case is from ThyssenKrupp for their connected elevators, and shows that ThyssenKrupp has connected 100,000 of elevators to their predictive maintenance solution, and these are connected using different connectivity solutions, cellular, LoRa, Ethernet, and this choice depends on the specific setting and the specific country where they are in. Just to go back to the initial poll that was talking about, the challenges of global connectivity. And another interesting one is smart logistics. Here in Hamburg, we have the port authority, which has commissioned a number of companies, including SAP and Nokia, to do 20 different projects on IoT, mostly for the management of the traffic within the port, both both the ground and marine traffic, and the management of shipments and warehouses. And also here they're using different connectivity technologies from cellular to non-cellular. And recently the port was also the subject of a 5G project called 5G Monarch, which has actually won an award at the NWC in Barcelona. And then we have smart energy, which is probably the most mature, if not one of the most mature use cases in IoT. Smart metering in particular, we have not just smart energy, but also gas and water. And also here, the connectivity solutions vary a lot depending on the location and the setting. You can have cellular, low power wide area networks are actually getting a lot of traction on this. We have a lot of mesh network technologies, both ZigBee or Wi-SAN and other options in the short and medium range. And also, last use case I want to discuss today is for smart city are connected street lights. So this is another use case with varying connectivity requirements. It's mostly used for the predictive maintenance of the light, for the real-time scheduling, and for the remote management of these lights. And also here, depending on where you go, you can find different kind of connectivity solutions, more or less the same that I mentioned before: cellular, low power wide area networks, mesh network. The image showed here is from Miami, where they sold 500,000 of the smart lights using Wi-SAN technology, which is a non-cellular. But just to show the huge variety of connectivity technologies. And my next slide is supposed to show you exactly this. So I have separated the huge variety of IoT connectivity options in 4 quadrants. The first one in the bottom left shows you low performance, short range wireless protocols. Mostly are the ones used in various sensor network applications within the manufacturing, within energy, buildings, smart home. Many of these are mesh networks. Then on the top left, we have more general purpose protocols such as Wi-Fi or Bluetooth, which are more recently being enhanced with the IoT features. For example, the Wi-Fi 6 protocol, which is the latest to arrive, is directed specifically at IoT, and the same is for Bluetooth 5. And then on the other side, we have options with a higher coverage. In this case, in the bottom right, we see mostly the low power wide area networks, which are specifically designed for M2M and IoT applications. They come in different shapes, licensed, non-licensed, with deep indoor penetration, different kind of energy consumption, and so on. And then finally, at the top right, we have wide area and high performance communication technologies, specifically cellular and satellite. Now, for today, our focus will be only on cellular technologies, which basically can be divided into categories. The first one is traditional cellular, which is traditionally directed at consumer applications, so to make phone calls, from internet browsing, or from 5G, which we'll discuss later. And then low power wide area networks, LTM and NB-IoT are the 2 cellular options. And in this slide, I want to show how these connectivity technologies are being used in the IoT today, and how we do expect this distribution of connections to be in the next 6 years. So the thing that should catch your eye in this slide is the fact that cellular IoT connections, which are the ones in light and dark blue at the top, as you can see, they represent just a minority of the total IoT global connections today. But their role is going to get bigger and bigger. So we're going to go from 8.8% of total connections today to 11.5% in 2025, according to our forecast. So, these are cellular connectivity is in general growing much faster than non-cellular connectivity. What are the technologies that are contributing to this? First of all, low power wide area networks, the licensed ones. In a study that we performed recently, we discovered how MBIoT and LTM have been getting more and more traction recently. MBIoT in particular is the one that is definitely coming out as the most popular option. It has a lot of traction in Asia, especially in China, and in other countries in Europe and in the US. Many operators are deploying NB-IoT networks, and we will start seeing more and more adoption for this technology. And then the second technology is going to be 5G. 5G is more for medium-term technology when it comes to IoT. We don't expect IoT connections on 5G before 2021, 2022, due to both standard being released in phases, and the second phase will not be ready before next year. And this is this is the phase where IoT use cases will be targeted. And secondly, also because investing in 5G technologies, deploying the networks is going to take a while. Operators will do that gradually, and so will come the adoption. It will be very gradual. But on the medium long term, 5G will eventually contribute a lot to the growth of M2M and IoT. Last slide from me today. This is to show you what are the reasons why people would be choosing cellular connectivity for IoT. And we selected 4 main reasons. So compared to other technologies, cellular IoT has, number one, a much better coverage. Cellular networks are present all over the world, in all countries. The coverage is nearly everywhere. Just a few places they don't have coverage, like overseas, maybe in the deserts. But everywhere else, you can find a cellular network to connect to. This is opposed to the new, for example, unlicensed low-power wide area networks, 646 LoRa. They are still early, of course, but the coverage is very spotty, or short-range networks which have a very small range and they have to be deployed specifically for the application. You don't find them there. Second reason is the deployment simplicity. So with cellular, you don't have to do any end user provisioning. So the end user gets the device, it just has to turn it on, and the device will automatically connect to the network without the need for manual configuration, which is a great advantage for IoT. It makes things much easier. Third reason is connectivity, security. Cellular networks have been around for 20 plus years. People know they are secure. They have authentication based on SIM cards, and they automatically encrypt data when they are sent. Other options such as Wi-Fi, you have to configure that manually. Not saying that cellular as the most secure, but definitely is very, very secure. And then the fourth reason, and the final one that I'm highlighting today, is the quality of service and reliability. So we do know that cellular networks are managed by network operators, which can guarantee a carrier-grade level of service. And at the same time, these networks are very robust, meaning that having the network under control constantly 24 hours by 24 hours, network operators can make sure that there are no outages in the network. And this is definitely a very good advantage over other technology. Again, I'm taking Wi-Fi as an example, because if you think Wi-Fi, the router, the gateway goes down, there is no way that you can discover it like straight away unless you're connected. So in the end, these, in our opinion, are strong 4 factors that play in favor of cellular technology. So with this, this is all from me. So I will hand it over to Philip, who's gonna give you more details on how BICS is helping his customers.
Thank you, Eugenio. Also, hello again. Let me start with a use case. When you love nice bikes, as I do, you want to lock them properly. One of our customers successfully launched a smart lock in one market and faced a challenge when he wanted to scale up to move abroad. They started with a SIM from the local mobile operator and fortunately evolved to a global SIM. And also they had a good idea to start immediately with the application in the cloud, so that could also be scaled. But at the same time, the security certificate was installed manually by unpacking the locks and connecting them to a computer. This is great when you have 10 devices. It could work if you have 100, then your game is over. Because you cannot ask your Chinese manufacturer to install certificates. That's not the way you want to go. Now, today, Sergey and I will explain how we crack this challenge with a global SIM and automatic device provisioning. As IoT can transform almost every vertical from finance over utilities to consumer goods, building, asset security, but also logistics, you need 4 things to make it happen. Enterprises must be able to achieve global coverage and connectivity at one shot, one platform, one solution, one global partner, and the only technology that offers that today is global roaming. The power of the cloud-based platforms is to offer all these benefits, such as scalability, availability, security, and low latency. These cloud providers, such as Amazon and the others, are really very valuable part of the ecosystem. And at BICS, we are very proud to be a partner of Amazon. The other important thing that enterprises need is turnkey automated platforms, offering the highest flexibility and control to manage fleets of thousands and maybe millions. They cannot go back to each connectivity provider in any country or in every country to manage or troubleshoot SIMs. If you remember the vote of the audience that the troubleshooting of connectivity is very, very important, then you want one central supplier who can handle that for you. And fourth, management should be easy. The reporting, the remote device provisioning, the management, and the software updates must be easy. This is what BICS is focused on, providing a turnkey global connectivity solution that offers an API-based pay-as-you-grow model for companies looking to integrate connected devices into their international business with simplicity, reliability, and flexibility. For most enterprises and business sectors, one key driver for the IT transformation is the potential to go global, as it allows devices anywhere in the world to connect and interact uninhibited by location. As enterprises become ever more interconnected, this offers a cost-effective way to connect across multiple regions. One of the reasons for the boom in IoT is the maturing of 2 trends. On one hand, it's mobile technology. I remember LTM and narrowband IoT mentioned by Eugenio, and the other is globalization of business. For this reason, IoT needs global connectivity to succeed. Global IoT is transforming the international business of enterprises. Without international cellular connectivity, the IoT market cannot reach its potential. Local deployments address only small-scale and isolated use cases. Cellular connectivity, on the other hand, offers ubiquity, built-in security, a global network of providers, flexibility of SIM technologies, including eSIMs. Mass-scale adoption of IoT will be driven by global enterprises rolling out connected device fleets with services and management that are delivered seamlessly all over the world. This has numerous advantages in terms of reach, consistency of brand experience, cost effectiveness, and business process optimization. The BICS cloud-based IoT platform handles every element of international connectivity. It is easy to implement now, no matter how complex the business, with a pay-as-you-go, scale-as-you-grow model. We offer one SIM, one platform. We are one partner for worldwide deployment. It builds on our roaming and international connection to over 700 operators worldwide to enable seamless global connectivity for IoT devices anywhere in the world. Crucially, it offers one SIM that provides seamless connectivity in multiple countries for any device. Having a Single SIM is vital as it allows for devices to be seamlessly connected all around the world. It is impractical and prohibitively expensive to swap the SIM or connectivity provider every time the device crosses a national border. The solution is completely designed for IoT from the ground up, so it is flexible and can be quickly customized to enterprise specifications. Supported by the widest and most advanced library of API capabilities in the market, making it easy to integrate with any backend system. We can also develop customized new APIs tailored to your requirements within just days. Our platform also incorporates lifecycle management for connected device SIMs, from setup to deployment to troubleshooting and real-time management, as well as billing capabilities. It helps to automate and control any IT deployment to deliver these functionalities. The platform billing capabilities enable companies to quickly and easily generate new revenue streams for connected services and business models. And this is possible because we have assets that we use for other business lines. This is our roaming hub, where we are physically connected to 150 mobile operators worldwide, and we also have commercial relationships with virtually all operators in the world. Let me just say one word about the company I represent. BICS is a global telecommunications service provider based here in Brussels. We are at the forefront of the mobile industry's transformation, and we are owned by three MNOs: Proximus from Belgium, Swisscom from Switzerland, and MTN, a group from Africa. And maybe there's one number you should remember, that as BICS, we are carrying 50% of the world's global roaming traffic. Now, to come to the topic of today, BICS and Cesanta, together, we have simplified the process for companies seeking to integrate cellular reach within Amazon or AWS, accelerating the time to market for IoT propositions. This off-the-shelf connectivity solution significantly reduces engineering efforts, cuts the time required to develop new products, and minimizes operating costs due to the power and capabilities of AWS IoT. So we built a ready-to-go secure AWS connectivity and provisioning solution. Let me return to our use case and the partnership. So more and more devices want to connect to Amazon IoT Cloud, but Amazon, they are very stringent on security, so it's absolutely mandatory that a certificate is installed into the device before it's allowed to connect. I always compare it that if I travel to the US, I have to show my passport. It's the same. I will be not allowed to cross the border into the US without my passport. No device is allowed to enter Amazon without a certificate, and the certificate has to be unique, just as my passport is unique. And then, so to SimForThings and Cesanta Vicon provide a secure, ready-to-go AWS connectivity and provisioning solution, enabling data reporting, remote device control, and device software updates that optimize brand protection. Let me conclude by highlighting who contributed what in the partnership. So BICS, as you might have understood by now, we provide connectivity, but also we can identify the device. Using that, Cesanta Vicon is a cellular connectivity module for secure and automated device onboarding, but Sergey will explain that. And we use all the capabilities of AWS, allowing low latency and high reliability, and allowing AWS customers to expand their geographic reach for IT footprint to over 200 countries. Sergey, that's all for me. It's up to you.
Thank you, Philip. Thanks very much. So I'm Sergey, the CTO of Cesanta, and I will explain a bit more technical details about the solution that we, together with our partners, BICS can offer So let me go to the next slide, please. Okay, so the Cesanta, we are a company that we specialize on embedded software and hardware, and we focus on Internet of Things. And our solutions are already integrated in hundreds of commercial products and deployed to over 1 million production devices. The idea behind this specific offer is to provide a connectivity module together with the cloud management service that makes it really easy to securely provision devices to the Amazon IoT cloud. And this solution could be extended to other clouds as well, not just Amazon. For example, it can work with Microsoft Azure or Google Cloud and so on. So the global provisioning of devices with Amazon IoT, it provides the global connectivity and solutions for mass rollout deployments. There are three main challenges for the big IoT deployment use cases. First is the adoption barrier, then the security, and the ease of use. So currently, there are no kind of de facto standards in this area, and pretty much every vendor goes and invents the wheel in this area, which certainly takes a lot of time from every vendor that provides a connected product. So, and we are trying to simplify this. So this schema roughly describes the provisioning process. Here in the center, you can see a connectivity module. So this is the embedded part of the solution. So this is a module with the cellular transceiver. This module needs to be embedded into your product, basically. So if you have a product that you want to make connected, you can stick in this module and connect the microcontroller inside your device with this connectivity module, and it will take care about the rest. So this schema explains the provisioning process. So when your device is completely blank and you delivered to the and deployed to the field or on the customer side, it's completely blank. It could be completely blank. It's not provisioned to your Amazon account. So a device starts, figures it out, it's not provisioned, and goes and talks to the well-known cloud service, vcon.io, saying, hey, I don't have any certificates. I'm not provisioned to my Amazon account, so please give me certificates. Then vcon.io cloud service goes to the BICS backend and saying, hey, BICS backend, I have a new device with your SIM. Please tell me, like, who's the customer of this SIM? And BICS backend replies back, so the customer A. And the vcon.io knows, okay, so the customer A, we know your Amazon account credentials. We can create a new device, register a new thing, IoT thing, get the certificates, and can upload these certificates to the new device. So, and then vcon basically pushes the certificates to the module, and from this point on, the vcon module is already provisioned to Amazon. It goes and directly connects to Amazon. So, and this whole provisioning procedure would not be needed anymore in the future. So from now on, vcon has certificates, Amazon certificates. And Similarly, the remote device control could be implemented. So this is done through the standard services provided by Amazon, for example, device shadow. So there is a vcon.io provides a management link to the module, and at any point you can go and change a device shadow on the Amazon cloud, which calls back to the module, and the module can command device to do certain actions depending on the shadow change. So, and this is a short video that, this is a short video which actually demonstrates this in action. So specifically in this video, what you see is the cloud part of the service, which is on the left. And on the left, you can see a table of registered devices with their status, with their IDs. So you can see there are a couple of devices online. And on the right-hand side, you can see a device with the vCon module. So the vCon module is on the right with the blue LED lighting, and a customer device, for example, your device, is on the left. It's from the left side of the vCon module with the red LED lighting on. So these two modules are connected together. So the vCon module is connected to your device's microcontroller, and they can talk. So they can exchange data and like send commands, send data, and vCon will relay this data to the Amazon, or vice versa. The commands could be received from the cloud and passed over to the device. And there is also another set of links. So the vCon module at any time can reflash a microcontroller. So it can forcefully replace the firmware that is running on this microcontroller and replace it with a new one. For example, for some reason, if some configuration change was made on your device which broke it, or a bad firmware was pushed, or for example, a new version of firmware is now released with better capabilities. So at any point, it is possible to go and reflash this device with a new firmware. And you can see in the video, I'm continuing on, so you can see that the device is turned on, it becomes online, and it gets the new. So what this fragment demonstrates is the totally new unprovisioned device. So in a sense, all you need to do if you're using vCon module, all you need to do to provision your device to the cloud is to turn your device on. Nothing else is required. So once your device is turned on, vCon goes out and connects and talks to BICS Cloud and gets the certificates from Amazon and provisions a device to your own Amazon account. And then you can even deploy your devices with absolutely no firmware running on the microcontroller. So you can burn the firmware later afterwards. Let me continue the video. So this fragment shows that the new device is provisioned. Now what we can see that the firmware that is running on a device is blank. There is nothing running on this device. So what we can do now is we can go and forcefully upload a new firmware, and it gets burned to the target device. So what it gives a secure way of mass provisioning a big number, like millions of devices, with pretty much no hassle, which is a big technological issue. when deploying a large number of devices. How to do it securely, that was briefly mentioned by Philip. Is you don't know to share any credentials of your company with any kind of manufacturing partner in other countries. And also, you do not want to provision each device one by one. It's a quite manual and expensive procedure. So this solution, it provides a way to automate this process, make it secure and fast. It enables the proactive maintenance and support for all of your devices. So your device essentially has two connections to Amazon or to some other cloud, and to Vicon and BICS backend, which provides an emergency link. At any point, you can go and talk to your device. You can update it, run specific functions on it, see the status, reboot, anything. It allows you to do the fast development cycles. It's really safe to push a really new experimental code on your devices without any fear of losing this device in the field. So you can update it at any point anyway. So this slide shows this is the video. It shows how the data could be transferred to the Amazon cloud. So it shows that the device sends the JSON messages to the MQTT topics, and now it shows the remote control over the shadow. So you can change the Amazon shadow using Amazon functionality, and your device gets the shadow delta and passes that delta back to your own microcontroller. So the life cycle of device involves many incidents where intervention is essential. Say there could be a network change, or the requirement to push a new firmware, or some devices may show some certain warning signs, or for example, they like reboot quickly or whatever, so they need troubleshooting, or the customer requested some changes. So all that is possible with the this management link that is provided to you by this solution. And the huge, very critical ability that this solution provides is the ability to reflash your device's firmware. So Vicon module doesn't know what is on your device's microcontroller. It doesn't know it, but what it can do, it can reflash it. It can replace this firmware at any point because it's physically connected to the specific lines of the microcontroller. And this ability is really critical because it allows, it gives you safety from the accidental device like breakage. So it's a big problem in the IoT deployment when you have a device in the field and you update it somehow, either configuration or firmware, and it hangs basically. And from this point on, it goes unresponsive, and it's really hard to do anything about this. So it's either a customer needs to like totally replace the device, or an engineer should be sent over. So it's a big problem for the vendor. It affects the revenues. It affects the vendor image. It affects customer security. Bumps up the restoration costs. So it's a really, really big problem. and the ability of the Beacon solution to, at any point, to replace the firmware and revive the device back to life is like absolutely critical, and basically solves this problem. So this basically slide summarizes the procedure. It's fairly simple. So the core of the functionality lies in the ability of Beacon module to replace the firmware on your device MCU. So you can put your firmware anywhere, basically, and the Beacon can take it and reflash your device. So this video quickly shows in the UI, it looks like a simple file upload. It's a really simple procedure. You should basically just go and select a file, and it's done. Obviously, for all this UI functionality, there is a corresponding API, so the same ability could be done programmatically for your product. So you can build in automation procedures and update your devices automatically. So this is all for me. Thank you. So I'm passing back to Jeremy.
Thank you very much, Sergey. There's plenty of information for us to chew on there. We've got a lot of questions in, so let's go to those as quickly as we can now. And the first question that I want to share with you is this. Can you elaborate a little about what kind of wide area connectivity technology, and the questioner cites LTE, LoRa, 3G, is used in those successful IoT cases that you cite in your presentation? So this is really a question for you, Philip, I think. And what's your thoughts about the preferred choices in the next 2 to 3 years?
Today, and also for this use case, we use 2G, 3G, 4G. So it's fully transparent. It's fully dependent on what's available in the countries where the service is deployed. Current hardware is typically 2G, 3G full compatible, as it was in this case. In the future, this use case could obviously also be served with narrowband IoT or Cat-M1, because we are talking about small data volumes and a data speed that's not so relevant. So you could reap the benefits of lower power consumption and lower costs by evolving to Cat-M1 and narrowband IoT. But we can also already serve these use cases today using LTE.
The next question that I wanted to go to is about your offering. And again, this is probably best for you for the moment, Philip. The questioner says, I understand that SIM for Things offers multi-networking in every country. And he wants to know, can I then select the best network for each of my devices, and how does it work?
Thank you. I saw the question among the list, and it's a really nice one. Indeed, we offer multiple networks, and in the end, we do not interfere. We will let the device choose the best network based on signal strength. Obviously, if the customer wants, he can let the device do whatever it does. It can also, in the device, choose preferences, or the customer can also, via either API or in the GUI, set the preferred network or bar the other network. For instance, in Nigeria, we've got a use case where one of the networks is not working well, where the customer simply bars the network and goes to the other two.
Yeah. Is there anything that you would add to that, Sergey?
Not really on my side.
Okay. I think this is something, a point where we can actually go to something that is particularly relevant to you. Could you talk a little bit about the security aspects of the solution?
Sure. So the overall solution uses security standards, so industry standards of security. First of all, the communication between the cloud and the module is over TLS. It obviously depends on the cloud which is used, but pretty much all the clouds now they use TLS protected communication. For pretty much all major clouds that we use, like Amazon, Microsoft, Google, we use mutual authentication, TLS mutual authentication. So this is what goes to the communication security. On the device side, we use the hardware which encrypts the flash. We use security elements. So it's pretty. So we use industry standards for securing both communication and the firmware on both devices and the traffic between the beacon and the cloud.
I see. Philip, this one is for you. Does the solution also provide some tools to charge my own customers for the usage and for the firmware updates?
So definitely, this could, for instance, be done using different APNs with different charging mechanisms. So definitely, we could set up the account so that the different types of usage of the SIM card, in this case, can be charged differently.
Would you add anything to that, Sergey?
So, I think that's mostly a question for the for Philip, because I believe that the question is about the the plans, the mobile plans. So
I've got a question on the. Sorry, go on.
Go on.
Yeah, I've got a question on the reliability of OTA, over-the-air updates. How is that best achieved? Who would like to tackle that?
Yeah, so there are two kinds of updates. First is when the beacon module updates the host microcontroller, basically your device. The reliability of that is achieved by the fact that the module can reflash the microcontroller at any point. So if for some reason, whatever reason it is, the update was unsuccessful, it is possible to repeat it. So this is first. And the second thing is when the module updates itself. So this is more like, this is a trickier case. And the reliability is achieved by a specific set of basically precautions. So the update is done never mutating the current firmware. It's done on the separate partition of the flash. And when the update is done, the firmware runs a set of health checks and commits the new firmware only after all of the health checks are done. If something goes wrong, whatever it is, either firmware hangs or it cannot connect back to the backend service, it rolls back to the previous version. And since the previous version is never changed during the OTA, so this mechanism guarantees the ability to roll back. So this is the quick summary.
There's a housekeeping question here, and an important one. Will we be able to share the slides? Just to repeat what we said at the beginning, we're very happy that from tomorrow we'll be streaming the full video and audio from the website iot-now.com, and that'll be available in about 24 hours. But on a more technical issue, there's one here from Franco. I think it's probably one for you, Philip. He wants to know, does global connectivity include everywhere?
So I wish. So obviously, in the middle of the ocean, there is no 4G coverage. Now, the exact coverage will really totally depend on where someone has put GSM antennas. But coverage globally is better and better also in continents such as Africa. And depending on the service, the coverage will also vary. But so the answer is, if the yes/no answer to this question is no.
No.
So if you really want coverage in the middle of the ocean, that could be satellite.
Question here: do companies have the option to choose different types of connections and costs for different types of deployments? I think I know the answer to that, but Philip, over to you.
I think so. In the end, the cost for network usage is simply based on volume and destination. So typically, we have an offer with how many networks do you want? Do you want all the networks in the country, or do you want only one network? So what's important for you, the best performance or the best cost? And it will depend on the volumes you buy, what price we can give you. But it's typically based on volume. There is no, for instance, no such thing as a low speed offer and a fast speed offer today.
Understood.
What's coming? So that's valid for 2G, 3G, 4G. But obviously, it's a big debate in the industry what business model there will be for narrowband IoT, because there the traditional charging per megabyte might not fly. There might be different models in the future, and there in the end, it might end up in if you have applications that are happy with narrowband IoT, you might come to a cost model with a fixed price per month, for instance, per device, disregarding the volume or the number of connections.
Okay, and we've just got time for one more question, which I'm going to throw over to you, Sergey. The questioner asks, what kinds of protocol is Cesanta embedding in IoT modules to allow IoT devices to communicate with AWS Cloud?
So the AWS Cloud, if we are talking about the AWS IoT, the transfer protocol they use is MQTT. So, and that's what the module uses. So it uses MQTT over TLS 1.2 with the standard dual mutual authentication. So that means that both sides of the communication, both client and server, they use certificates to authenticate.
Well, thank you. Thank you, gentlemen, for taking questions of all kinds from all sorts of places. As I say, I'm afraid that is all we have time for. The aim of this webinar, as you know, has been to try and establish how enterprises can connect IoT devices to platforms, how they can do it globally, and how they can do it at scale. We've heard an awful lot that indicates answers to that, and I know that our panelists would be happy to take your questions offline if you've got further things that you want to discuss. There is, I'm sure, more to discuss, but I'm afraid that is all we have time for today. Please remember, bookmark our website at iot-now.com, and there you'll find the very latest news, plus more videos, blogs, events, other webinars and interviews. And tomorrow you can stream this webinar from that site. It just remains for me to say a very big thank you to all of our panel. Philip Gosselet of BICS. Thank you, Philip.
My pleasure, Jeremy. Thank you to you. And thank you for all the attendees as well.
Indeed. And to Cesanta's Sergey Lyuk. It's been great to have you here, Sergey.
It was great being here. Thank you, Jeremy.
And finally, Eugenio Pasca of IoT Analytics. My thanks to you too, Eugenio.
Thank you, Jeremy, and thank you also to Philip and Sergey and all the attendees.
Most of all, as we say, ladies and gentlemen, we are all grateful to you for joining us around the world. We really do appreciate the time you've spent with us. From everyone here at IoT Now, please enjoy the rest of your day. Bye for now.